Hello, so I'm sorry to say that unfortunately we're back to the glare, but hopefully that will not be too big of an issue. So now we're doing a unit on differential equations. This is one of those units I think in all the videos I've said, later we'll do a unit on differential equations. Now we are here. This unit's on differential equations, and then near the end we'll be talking about logistics slash carrying capacities, but basically just fancy words for things that you already know how to do. But um, this unit is on differential equations, so first it's important that you know completely what a differential equation is. Now, I've told you in the past that differential equation is just a derivative. And yes, that is true. If something can be made dy dx, then yes, that is a differential equation. However, in this unit, it's going to become a little bit harder. We're not just going to be dealing with differential equations such as this equals x squared plus 2 or something like that. We're going to be dealing with things that don't just have x's in them, but they also have y's, for example. So, a differential equation by definition is an equation that contains at least one rate of change or derivative. So that could mean that there are variables in there that aren't exactly easy to deal with, such as dy dx. But what if this was like 3xy? How can you find what the original equation is, aka how can you find the antiderivative of all this? You might think you already know how to do this, but the way you probably think of doing it right now is kind of messy. How to do this is where we would do something called separation of variables, and we talked about this a couple of units ago, but basically what we're going to do is you want to have all the x's on one side, all the y's on the other, and that means the dy's as well. And so in this case, we would multiply over the dx, so you get like dy equals 3xy dx, and then we can subtract the y over, so you get 1 over y dy equals 3x dx. And now that they are on their own side with their own variables, you can go ahead and take the antiderivative of both sides, and you'll get ln y absolute value plus c equals 3 over 2 x squared plus c. And because there's two c's being added together, c is any constant, so you can actually just kind of subtract one of the c's over and make it like ln y equals plus c, because that could mean that that's this c plus this c, that this c plus this c still equals c, because any constant plus any constant still equals any constant, you know? And then the biggest thing you need to remember when doing this is that you have to keep the c with the thing. So as we know, to solve for y equals e to the 3 half x squared plus c. My point is you can't just take down, like, disregard that c. That c must stay intact. And I'm going to talk about in the next video how you actually can simplify this a little bit and get something that looks kind of like this. But we'll talk about that next video. When I talk about, I believe, yeah, next video we'll talk about when they're going to be like giving you kind of word questions like this. So basically, all you have to do for differential equations is you need to separate the variables. Another one would be, let's do y squared cosine x. That looks a little messy, but it really isn't. You just have to, you can do this even in your head. Divide over the y squared equals cosine of x dx, and then take the derivative of both sides. This would be, I believe, negative 1 over y, right? Because y over, yeah, negative 1 over y equals sine of x plus c. And then just solve for y. But remember to keep these two together. It's super, super important. So then you can get that y equals 1 over negative sine x plus c. Remember, negative c and plus c are the same thing because you're adding, it's a constant. It can literally be any number, but my point is you can't just write this like out here. You can't do that. You have to keep it in the denominator where it was before. Just make sure that you're doing your operations in the correct order, and you shouldn't really have a problem. And that's the basic differential solving.